If you're walking into that exam thinking that just memorizing the density formula is going to magically guarantee you high marks, you're setting yourself up for a massive disappointment. We're jumping straight in right now, zero fluff, to bust the biggest measurement myth out there and give you the exact high mark strategy you actually need for Cambridge IGCSE Physics.
So here's the thing. Writing down rho equals m over v on your paper, that's just the absolute bare minimum. Honestly, relying on that alone is a painful learner mistake that will literally tank your grade. The examiners already know that you know the formula. What they're actually testing is your ability to handle the practical reality of extracting those measurements in the first place, and that is exactly where so many students just bleed marks.
Let that number sink in for a second. 0. Because this is the harsh reality of the Cambridge 0625 mark scheme. Even if you punch the numbers into your calculator perfectly, and your math is completely flawless, you can still score a grand total of 0 marks if you fall into ordinary revision traps. The math absolutely will not save you if your physics method is fundamentally flawed. You might be wondering, why does ordinary revision fail so often? Well, it's because examiners actively hunt for specific pitfalls. You write the correct number, but forget the final unit, boom, you drop the final mark. Round off your numbers halfway through a multi-step calculation. You're going to arrive at an inaccurate conclusion and lose accuracy marks. What if you suggest a weak practical improvement, like just saying, be more careful? 0 method marks. Plot your graph with a nonlinear scale, you lose your gradient marks entirely. This is why just reading the textbook isn't enough, guys. You have to train for the exam's specific rules of engagement.
And look, this isn't just me being overly strict here. If we look directly at the official syllabus structure, you'll see that measurements and units are placed at the absolute foundation of the entire course. Specifically, sections 1.3 through 1.5 strictly demand mastery over measuring length, time, volume, and density. It's like building a house, right? You cannot build on a shaky foundation. You absolutely cannot master forces, energy, or thermal physics if you don't first know how to measure them accurately.
So before we dive into the advanced stuff, here is a quick win for you to instantly secure easy marks and stop the bleeding. When you finish a calculation, you need to build a reflex to immediately check 2 things. 1, did I write the correct unit? And 2, is my final answer to a realistic number of significant figures? Usually that means matching the least precise piece of raw data they gave you in the question. That simple 2-second check, that will save you half a grade over the course of a full paper. Now, in just a moment, I'll show you the examiner clue that changes the practical answer completely, a clue that trips up thousands of students every single year. But first, you absolutely need the structural framework that makes that clue completely obvious to spot. Trust me, leaving now means missing the key to unlocking the toughest evaluation questions on the paper. All right, let's get into the top band answer framework.
If you want to secure high marks for any explain, describe, or evaluate question in IGCSE Physics, you really need a surgical approach. You can't just write a paragraph of random thoughts and hope the examiner magically finds a mark in there. Here are the 4 mandatory steps you need to build a flawless, examiner-safe response. Step 1, state the core physics concept. Step 2, back it up with specific evidence or data right from the question. Step 3, connect them using logical scientific reasoning. And finally, Step 4, deliver it all using precise examiner wording. When you interlock these 4 pieces, you leave the examiner with absolutely no choice but to give you full marks.
Let's talk about Step 4 for a second, because examiner wording is basically your exam's safety net. You know, in everyday life, you might call it a weighing scale, but in Cambridge Physics, it's a top-hand balance. You don't look closely, you read at eye level to avoid parallax error. Using exact physics terminology for your apparatus and variables, instead of just vague conversational descriptions, proves to the examiner that you're a serious physics student. Okay, flawed versus perfect answers. Let's actually see this framework in action. Take a look at this tragically vague student answer. Used a ruler to get volume, got the mass, divided them. Yikes. Now compare that to a top band answer. Measured volume with a displacement can, measured mass using a top pan balance, applied density equals mass over volume. Do you see the difference there? The flawed answer sounds like a casual text message to a friend. The top band answer reads like a precise scientific methodology. Let's grab a red pen and act as the examiner for a second. Why exactly did that flawed answer fail so spectacularly? First off, no specific apparatus was named. How did they get the mass? Did they just guess? Second, they totally failed to mention controlling any variables or practical techniques to ensure accuracy. Third, the scientific reasoning was entirely vague. And to top it all off, units were completely ignored. It lacks evidence, it lacks terminology, and honestly, it just bleeds marks. Next up, a quick spot the error challenge. Let's see if you can find the anomaly. Now it's your turn. I'm inviting you right into the examiner's seat for an interactive challenge. We've got experimental data here for calculated density across 4 trials. Go ahead and pause the explainer if you need to, and predict. Where is the glaring error in this data set? What is the one thing sticking out that completely ruins this experiment? Did you catch it? It's 8.2. Trial 3 is a massive anomaly. If you just blindly punch these 4 numbers into your calculator to find an average, you're falling into a huge trap. Including this anomalous 8.2 value in a final average would completely destroy the accuracy of your final conclusion. It essentially skews the entire result way off from the true value. And that brings us to a vital examiner-style definition that you absolutely must memorize: reliability. Reliability is all about the consistency of a measure. You heavily improve the reliability of an experiment by repeating trials, like we just saw with the data. But crucially, you must actively identify and remove anomalies before calculating your means. That is exactly how you prove you are critically evaluating data and not just doing basic arithmetic. All right, let's hit another checkpoint. This is a classic Cambridge question that tests your practical investigation design regarding length and uncertainties. The question is, how do you measure the thickness of one single sheet of paper in a way that actively reduces measurement uncertainty? Take a second to think about your apparatus and your method. And here is the perfect top band answer. The trick is, you don't try to measure one sheet. It's way too thin and the percentage uncertainty would be massive. Instead, you measure a stack of 500 sheets with a micrometer screw gauge. Then divide that total thickness by 500. This brilliantly illustrates how to practically minimize percentage uncertainty by scaling up the measurement. It uses the right terminology, the micrometer, and gives the exact mathematical step to find the single unit. So that leaves us with an unresolved problem. What comes next? Think about it. You now have the 4-step framework. You know to watch out for anomalies, you know the exact terminology to use for measurements, and you know how to reduce uncertainty. But knowing how to measure things, that's really just chapter 1. With time running out, the massive question is, how do you apply this exact high-mark 4-step strategy across forces, energy, thermal physics, electricity, and everything else in the syllabus when you only have a few days left before the exam? You just can't rely on ordinary reading anymore. Exam survival requires serious action. So your mandatory next steps are crystal clear. Discard your old ordinary revision habits immediately. They're just way too slow. Start implementing this 4-step framework for every single past paper question you do today. And most importantly, you need to unlock the 7-day revision map that maps this high-yield strategy across all your remaining topics. Guys, this isn't optional, it's an absolute necessity for your final grade. Now, before we reveal that final map, you need to make sure you're locked into this exact system. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Listen, your exam strategy is currently incomplete. To apply the framework we just built across the rest of the hardest topics in the entire syllabus, you need to head over to the Physics 0625 Last 7 Days Revision Map Explainer right now. Are you going to let another easy grade slip through your fingers, or are you going to master the rest of the syllabus today? Click it right now and let's get to work.